this lecture is about all of the components that go into the construction of a typical residential wall system that starts at the ground floor with the footing and goes all the way up to the roof on the second level. And what you're doing with this project is you're creating your template for residential, and the dimensions in there in Revit are not accurate in terms of what the real world is for elevations. And so I'm going to explain what those elevations are that you have in the presentation that you're following, and I want you to try to understand why all the numbers that go into creating that elevation that add up to those values, because your foundation starts at minus 11 feet 2 1/8 inch, I believe, which is the bottom of the footing. So how do we get there? The one thing that you're starting at, and the one thing that Revit has correct is that 0 is your main floor level, which is the top of your plywood on the main floor. So let's start with the ground. When you're building a house, I'm going to have to change colors here. The first thing you do is you dig a hole in the ground. And it's usually 18 to 24 inches wide. This is the footing, and what goes into the footing on a residential structure depends upon where in the country it's built. If it's the kind of sandy soils that they have in Texas, it's going to be a different requirements for the footing as it is with the Georgia red clay that we build on here. The red clay is a really good dirt to build in. It doesn't shift. It compacts extremely well. I mean, clay compacts almost as hard as concrete. So our typical footings may only be 16 or 18 inches wide. That's something you have to look up in a code book to be sure. But usually you dig down about 8 inches in the ground, and then when you form it up to be able to pour your footings, you put some 2x4s here, which gives you another 3.5 inches, we'll call it 4, so that you can dig a footing. You pour a footing now in this trough and fill it with concrete, and so with the footing that I'm giving you instructions to set up in your Revit template is 12 inches deep. That's the depth of the footing, and it starts here at I'm trying to figure out which way I want to go. It starts here at the bottom of the footing. Your BO level is, and somebody check this to make sure I'm right, is minus 11 feet 2 1/8 inches. Is that right?
Yep.
Okay. The top of the footing is going to be where? The TO, if this is a 12-inch deep footing. I don't know why you're grinning so much, other than the fact that you're low riding in that chair.
10 to 1/8.
Okay, minus 10 foot 2 1/8 inches. All right, what sets? There's two components of a home that are constructed and actually they're both poured on top of this footing. The footing is the first thing that goes in, and after it's cured or after it's dried for a day, you're ready to come in and start forming up for the next component that you're going to build. What is that next component, Jack? Slab is one of the components that sits on the footing, but it's not the next one. Austin? Basement is in the name, but there's a second part of that term. Jack? This is the footing.
Basement.
What surrounds the basement?
Third.
The walls. So your basement walls, and those are poured. In Georgia, we do mostly poured concrete. Some areas of the country will do block walls, and then I don't know much about them. I never built block walls. I always did poured basement walls. In the case of our model here, we're going to figure that as I'm just going to put a break line in here. We're going to figure these as 9-foot poured concrete walls. And so this will be a total distance of 9 feet here. And so the top of my wall is at what level? Minus 1 foot 2 1/8 inches. Okay. Now we'll go ahead and cover the slab next, Jack, and because that's actually the next thing that happens in the construction process. But once you get the footings and the walls poured, then you come in and you do your plumbing in the basement, and you get that inspected and improved. You pull these form boards off, and you bring in 4 inches of gravel. And then on top of the gravel and on top of the footing right here, you pour 4 inches of concrete slab. And so in your presentation on Google that's showing you how to set this up, I'm letting you all do the math. And so I'm just going to draw this out here, and I'm going to put a question mark. You're going to do that math for a 4-inch concrete slab that goes right here. Now let's continue on up. What goes on top of this wall, and it's a framing component that you were tested on yesterday, which is the bottom component of any wall that we built. And in this case, it's not a wall component, but it has the same name. What is that? A sill plate. And so the typical sill plate, if we're doing like a 10-inch concrete wall that's 10 inches wide, which is pretty common when you're doing a 9-foot high wall. I'm going to go ahead and show that dimension here. 9 foot high is the actual concrete wall. The forms that are used are 9 foot tall. We usually put a 2x6 plate up there. So what is the thickness of that 2x6? It's not 2 inches. And you guys should know this. It should be like falling off a log. It should be part of your DNA by now. A 2x4 or a 2x6 is 1.5 inches thick. 1.5 inches thick. I've lectured on why that is plenty of times. I'm not going to go back into it. It is because the lumber shrinks, and the kerf that the big saw blades in the mill are wide, and there's a lot of kerf. There's a lot of sawdust produced, and the lumber also shrinks. And that may be totally wrong, but it is what it is. It's 1.5 inches thick. And that's my excuse for it, and I'm sticking with it. So we've got 1.5 inches here of sill plate. Now, just a side note here, what is special about that material that sits out here on a concrete wall that can get moist, Jack? Yes, it's a pressure-treated piece of lumber which resists rot from moisture, and it also has another feature that it resists. There's one little type of insects that don't like to eat the chemicals that are infused into the lumber. The chemicals that were used to be infused were arsenic, but the EPA got smart, and because that arsenic was leaching into the ground, there was some dangerous chemicals in areas that had pressure-treated lumber on the ground. So that was outlawed, but on top of the pressure-treated sill plate now, and a couple other side notes, because this is something I want to touch on too. If this is the inside of our basement, and this is the outside of our basement, and after you strip these form boards off, this is the inside of the basement, this is the outside. What's going to be out here?
Dirt.
Dirt. There's going to be a whole lot of dirt out here. And that dirt, the pressure of that dirt, and the pressure is horrendous when the dirt is wet. What kind of forces is that going to apply on the wall? I'm giving you a hint. It's going to try to move the wall this way. So when you pour these concrete footings, what we do here in Georgia, there's other ways to do this, is we stick a piece of 3/8 inch or 1/2 inch rebar, right? And does anybody know how they cut rebar on a job site? They have a really big device that'll just pinch it, cut. It has like 4-foot handles on it, and you can stick the rebar in there and just cut it with one whack. But anyway, the rebar that's put about every 3 or 4 feet, that's buried down in the concrete while it's still wet. And just a note on OSHA. Technically, once you do that, OSHA requires you. I'm laughing about OSHA because the number of deaths and severe accidents per capita of worker in the United States had been declining at a steady rate over the course of history. And then when OSHA was implemented, the number of accidents and deaths continued to decline at the very same rate before OSHA even existed. And why is that? Because bosses don't want their employees to get hurt. And this is a political commentary, but it just goes to show that sometimes government regulatory agencies don't really help the problem any. Some things tend to take care of themselves just because of human nature. So that's my conservative view, and I'll probably have to edit it out of this video. But OSHA makes you put little plastic caps on here until you pour the wall so that nobody hurts themselves on the end of that rebar. Okay. So this lecture is the battery still lasting on there? Is the light still flashing?
It's still flickering.
Okay. I better move on quick. What's going to sit now on top of this sill plate? Jack.
Foundation.
This is the foundation.
Stud.
The first floor. And so we call it a floor system. And the floor system consists of two components. A joist and, well, the band is part of the band is right. That's another component that's part of the floor system. But what sits on top and is glued and nailed to the joists? Here's a clue.
It's a thin.
It's 3/4 of an inch thick. What do you walk on?
Floor. Hardwood.
What's the floor made out of?
Wood. Hardwood.
What kind of wood? Yes, plywood. And how thick is 3/4 of an inch plywood?
3/4 of an inch.
It's really 23-30 seconds. What? But you know what? We're just going to call it 3/4 of an inch, and that's our story, and we're sticking with it. So there are a lot of different types of joists for a floor system. Two of the most typical are, well, three, would be 2x10s, shorter, smaller spans. 2x12s, you can get a bigger span and still carry a load out in the middle between one bearing point and another. And I-joists, which are engineered lumber. The way I'm having you set up your Revit template is for an 11 7/8 inch I-joist. And the reason it's 11 7/8 inches instead of 12 is a story that I won't get into. But it actually is totally logical. So what we have here sitting on top of this now is an I-joist, which is 11 7/8 inches. And I'm drawing it like that because it has the top strand and the bottom strand, and then it has the wafer board in between. And just an interesting little structural note about I-joists is the material typically has these little knockouts that you could just tap with a hammer, and this inside wafer board, or OSB, which is typical of the material, will knock out so the electricians have a hole that they can run electrical wires through without having to drill. But what's interesting about these is their strength, and you know what, I need to add one thing here to my little illustration of this wall. I need to have that band. And the band can also be plywood. But where would you think we could put the largest hole, like a hole we wanted to cut that was big enough to put a piece of 6-inch pipe through? Would it be near the wall, or would it be near the center of the span?
Near the wall.
That seems logical. But it's in the center of the span, all the way over here, is where you can put the larger hole. And as you get closer and closer to the wall, this center part of the I-joist, the size hole you're allowed to cut out gets smaller and smaller because of the way the product holds the loads. The top member and the bottom member are in tension. And that's something that is easy to mistake, because logically it seems like you could have a big hole out here and a little hole there. But that's the advantage of I-joist. That's why I'm having you put it in your template, because they are the best floor system, I think. And I used them. In fact, I was the first builder in Peachtree City in 1989 to build a house with the product that was just then released by Trust Joist International. They were called TJIs, and they promoted it as a silent floor system. The reason they called it a silent floor system is because this plywood here that's nailed to the top, when it gets nailed in, it's getting nailed into this top strand, which is a laminated material. And so unlike a conventional 2x10 or 2x12 floor joist, the nail is not going in between the grains that run that way. And when the wood dries out, the nail can move up and down and squeak. The nail was going into a laminated material where it was going through layers of that laminated material, and it would hold the nail a lot better. So the nails were, so you were very likely to get squeaky nails in your floor system over time. You had a question?
You can walk silently.
Yeah, and so they promoted it that way. But you know what? Silent floors still did squeak. One of their advertising campaigns showed an elephant on the floor. But anyway, so we've got an 11 7/8 inch I-joist and 3/4 of an inch plywood. My writing is horrible here. And if you add all of these things up, you're going to get to a level here for the top of the plywood of 0 feet 0 inches. That's your main floor level. Okay? So let's move over to, let's go from here on up now. I'm going to erase this. I may give you an assignment where I have you draw that out, sketch that out.
Oh, I'm good.
That might be the test. I have you sketch it out.
Oh.
Or better yet, I can have you, I'll have you sketch it out. But so we've got our plywood here at the 0 level, and that's the top of the plywood that's at 0. We're building our first floor walls. What's the first thing we put on? The bottom level.
No, that's the
sill.
The sill.
That's the sill. All right, so let's just break this wall. And what do we put on top of the studs?
Excellent.
And
That's the top plate. And
the
then
first one is, that's right, the first one's the top plate, the second one is the tie plate. And then on top of that goes our joist, which could be either a ceiling joist or it could be the second floor. In the case of our model, it's both. It's because it's going to be the second floor and it's going to be the ceiling for the first floor in this model that we're building. So we're in your model, in the template you're creating. I'm losing some attention, so hang in with me, and I'll try to speed it up. Jordan, go ahead and wake up. We're using 9 foot. We're building your model. Your template is going to be set up for 9 foot ceilings, what we call 9 foot ceilings on the first floor. But it's not. The studs are not 9 feet, and the distance between the top of the plywood and the bottom of the joist for the second floor or the ceiling is not 9 feet. It's 9 foot 1 1/8 inches. And so if you subtract an inch and a half, and an inch and a half from that, you end up with the length of a 9 foot stud. Does anybody know that off the top of their head? Nope. The length of a 9 foot stud is 104 5/8 inches. Now, who can do the math and tell me what the length of an 8 foot stud would be?
96 and 5 inches.
96.
See how good they are at math?
91.
Yes, I heard it. Who said it?
92 and 5/8.
Thank you. 92 and 5/8. Well, 8 foot ceilings are not popular nowadays at all. Almost all new homes are built with 9 foot ceilings on the first floor. It's just, especially in a community like Peachtree City. And so that's why I'm having you set up your Revit template with 9-foot ceilings. Do I still have power running on the camera?
You're good too.
Austin?
Why?
Because it just feels bigger. The rooms feel bigger. So the stud is 104 5/8, and so if you add all of this up and you put 3/4 inch plywood, which is not really 3/4 inches, how much is it? 23,
23,
30 seconds. Yeah. You get up to a level here, which I have on your instructions for your template, of 10 feet, 1 3/4 inches. And that all adds up. Now I'm having you add an attic level in your template. And I'm not telling you how to do all this stuff, but by the end of the class today, I want you to have your all your elevations set in the template and then go on to the next steps in the instructions there if you have time. Any questions about all of this? The only dimension you're not giving is that height of the basement level. You have to do the math to calculate that out. Okay, get to work. Have fun.